Okay, now we're going to be working with the double angle identities. So here we have sine of 2x, where the 2 is attached to the theta. That can be simplified to 2 times sine of theta times the cosine of theta. For the cosine double angle, cosine 2x, there are actually 3 different versions it can be rewritten as. Cosine x, cosine squared x, subtract sine squared x, or 2 cosine squared x subtract 1, or 1 subtract 2 sine squared x. All right, the reason that there are 3 different versions is right here we can rewrite cosine squared or sine squared. Remember, sine squared x plus cosine squared x is equal to 1. Well, we can rewrite cosine squared x as 1 subtract sine squared x, and then subtract sine squared x, and this other subtract sine squared x, that's where we get the subtract 2 sine x. And then if we did the same thing over here, 1 subtract cosine squared x is equal to sine squared x. So you get the idea. There are 3 different versions. And then for tangent, let's see if I have the tangent ones over here. It might be down below. All right, so I'm going to get started on the double angles here. So this is what we know. We know that cosine of theta, so cosine is negative. So let's see, cosine is positive here, and cosine is positive here. And we know that, so cosine is going to be negative here, here, and that where we're going to be talking about is between pi and pi halves. So here is pi halves. So we're going to be talking about this quadrant, and I may already have that. I do. So what you're going to do is you're going to draw a triangle with the theta right there. And what we know is, here's the hypotenuse, here is the adjacent. So this side is -8. Here we have 17, and we need to find sine of 2 theta. And remember, in order to do that, we need to find the cosine, the sine and the cosine, right? So let's find the sine. In order to do that, we need the opposite side. So 17 squared subtract -8 squared is equal to, let's see, 17 squared is 289, -8 squared is positive 64. You subtract those things, you get 225. Take the square root of that. This side is going to be positive 15. I think I have most of that written down here. All right, so we simplified all that. This is positive 15. All right, so cosine theta, we already know is -8 over 17. Sine theta, well, here's opposite. Here's hypotenuse. So we have this as 15 over 17. And now you're just going to multiply that out. So it ends up simplifying. So 17 times 17 is 289. 2 times -8 is -16 times positive 15, or in your calculator, 2 times 15 times -8 is -240. So the sine of 2 theta is equal to -240 over positive 289. So, and let's see. So here they give us some more information, and we need to find cosine of 2 theta. Well, they give us the tangent. Tangent, we know, is opposite over adjacent, and we're between, theta is between 3 pi, so it's gone all the way around the circle. So here's 0 and 2 pi. Here is pi. Well, 1 pi plus 2 pi, so this would be 3 pi. You get the idea. This is pi halves plus 2 pi. That would be 5 pi halves. This would be 3 pi halves or 7 pi halves. And this tells us it's between 5 pi halves and 3 pi. So again, we're talking about this quadrant. And that's good because it does tell us that tangent is negative And so when we draw our rectangle, the opposite side is root 10. That's positive because it's above the x-axis. And this right here is negative 3. And we need to find cosine of 2x. Well, either way, we need to find cosine or sine, which we need to know the hypotenuse. And I think I probably did that down here. So, I don't, it looks like I didn't. So, root 10 squared plus negative 3 squared is equal to the hypotenuse squared. Well, root 10 times root 10 is just 10. Negative 3 squared is just 9. So we have to take the square root of 19, and there's our hypotenuse. So let's see. Cosine of this theta is going to be negative 3 over root 19, and we could simplify that, but I'm going to leave it just like this right now. And sine of theta is equal to root 10 over root 19. All right, so I'm not sure it matters which one. We can use any of these. I'm going to keep it simple. I'm going to use this one right here, because when we square it, both of those are going to go away, and we know when it's squared, it's just 10 over 19. So I'm going to plug it in now. So cosine 2 theta is equal to, where's that right there? 1 minus 2 times sine squared. Well, sine is root 10 over root 19. So then we have is equal to 1 subtract 2 times 10 over 19, which is equal to 1 subtract 20 over 19. Well, 1 is the same thing as 19 over 19. 19 over 19 subtract 20 over 19 just gives us 1/19. So cosine of 2 theta is equal to 1/19. I should have actually made a lot more room with that. But anyway, so there we have that one. And let's see if we can come down here and see if we've got a tangent one. And here's a tangent double theta right here. Here's the formula, or the identity right here. And guess what? We only need to know the tangents. So this one is pretty easy. The only thing we need to know is which quadrant. And we're between 0 and pi halves, which is great because everything's going to be positive. We don't have to worry. We can just plug that in. So tangent 2 theta is equal to 2 times the tangent, which is 4/3. Let me erase that and write that a little bit better. Tangent of theta is 4/3, so 2 times 4/3 over 1 subtract 4/3 squared. And then you're going to need to simplify this. 2 times 4/3 is 8/3 over 1 subtract 4 squared is 16, 3 squared is 9. 1 is the same thing as 9 over 9. 8 over 3. 9 subtract 16, we have negative 7 over 9. We don't want an improper, we don't want a complex fraction, so we're going to multiply top and bottom by negative 9/7. And then those cancel. And then think about your algebra. Diagonally, these will cancel. 3 goes into 3 once. 3 goes into negative 9, negative 3 times, and multiply straight across. 8 times negative 3 is negative 24. 1 times 7 is 7. Therefore, the tangent of 2 theta, or 2x, is equal to negative 24/7. Ta-da! And that's it. These are pretty easy. You really have to pay attention to which quadrants and making sure that you're putting the right thing in the parentheses. That's it.